You are welcome back to the continuation of permutation and combination. In this video, we want to look at permutation of R objects from n different objects. In our previous video, we looked at permutation without repetition. Then we also looked at permutation with repetition. Now, this is the fourth video which we are looking at permutation of R objects from n different objects. By the end of this video, you should be able to arrange objects in a row from n different objects. Solve questions involving permutations of R object from n different objects. Here, when I give you a word like math, and I ask you, in how many ways can you arrange math if you want to select only two of the letters? So you can think of arranging MA, you can think of arranging TH, and so on and so forth. I mean, picking some out of a lot. We'll start with a question. The question is, in how many ways can we fill 4 vacant boxes with 6 different pebbles? 6 different pebbles. There's no repetition here. But we only have 4 vacancies. It means, in how many ways can we select 4 out of the 6 to form or to arrange in a row? All right. And so here we are going to ask ourselves a series of questions. And the first question is, how many ways can we fill the first box? The first box. How many ways can we fill the first box? You can see that all the pebbles have the opportunity of filling the first box. So the first box can receive 6 different pebbles, or 6 ways we can fill the first box. So let us assume that we put in first pebble into the first box. Then we've taken one of them has taken the position already, so we're left with 5 pebbles. And then the second box can take how many pebbles, or how many ways can we arrange the 5 pebbles in the second box? Which means all of them can be possible, so we have 5 ways. Then assuming we put blue also in there, then we have 4 left. How many ways can we fill the third box? And automatically that becomes 4 ways. Beautiful. Then the last one has 3 ways to fill. So in all, what can we see? How many ways can we fill all the 6 if 4 vacancies are available? Becomes 6 times 5 times 4 times 3. And what this means is that we have 6 permutations, but 4 vacancies are available. So we can write our answer as 360 ways. And this can also be written as 6 factorial, which means 6 letters are involved, divided by how many vacancies? 6 minus 4 factorial vacancies will give us the same value. And so instead of writing 360 by 5, 6 times 5, 4, and 3, we can also write 6 factorial divided by 2 factorial, which will give us the same way. And in permutation in terms of formula, we use 6 permutation 4. So 6 permutation 4 simply means 6 factorial divided by 6 minus 4. And that will give us the 6 over 2 factorial ways. Let's take another example. It will help you to understand better. In how many ways can we fill 3 vacant shelves with 7 different books? Here we have 7 different books here. In how many ways can we fill 3 vacant shelves? Let's see. We can say that, okay, let's fill the first shelf with 1 book. All right. What it means is that the first shelf can take 7 different books, so that can be 7 ways. Then the second can take 6 different ways. All right. And then the third can also take the remaining. So the first one gave us 7 ways to fill the first shelf. The second is giving us 6 ways because there will be 6 left. Then after the second has taken 1, then the remaining one will be 5 ways. And when I multiply 7 times 6 times 5, it's the same as saying 7 factorial divided by 7 minus 3 factorial, and that is the same as writing 7 permutation 3. All right, and so here we see this value stand for 7 permutations, but 3 vacancies are available at a time. So in general, this is what we want to write. In general, the number of permutations or arrangement of R object from n unlike object, that means there is no repetition, take note of that, is given as n permutation R, and the formula will be n factorial divided by n minus R factorial. So if there are 8 items involved, I will say 8 factorial. How many am I selecting or picking out of the 8? If it is maybe 3, I will say 8 minus the 3 that I'm picking, also factorial. And that is the formula for permutation. All right, good. Now let's take some few examples and see. In how many ways can 10 people be seated on a bench if only 4 seats are available? And I'm sure that is very cool for you to do. You can just say this is going to be 10 permutation 4, and then the answer will be 50, 40. You can try example number 2. Pause the video and try it. Sure. I'm sure you had your answer to be 10 permutation 3, or 10 divided by 10 minus 3. In how many ways can first, second, and third prizes be awarded in a race if there are 10 competitors? So 10 competitors, and we are picking 3 positions, first, second, third, and that becomes the answer. The next question, find the total number of different arrangements using any 3 letters of the word chemistry. Take note that chemistry, there is no repetition, and we are picking 3 letters to arrange in a row. I'm sure once again your answer came as this, 9 permutation 3. That's 9 permutation 3. I didn't put the final answer there, sorry for that. But your answer seems to be right. Then the last example under this, in how many ways can the first, second, third, fourth, and fifth prizes be awarded in a class of 25 students? Good. You had your answer to be that. With this, we come to the end of this video. The next video, we are going to look at conditions. For example, if I say, how many ways can we select chemistry, or 3 letters from chemistry, if maybe 2 of them should not move together, or 2 must always be together? I mean, there's a condition attached to the question. So we'll look at that in our next video. Thanks so much for watching.